And so with that, um, we're going to now move on. Um, and
Yes, so we have a great session. Thank you so much, Mike. Thanks, Roger. So we have a great session now with a live demos on Data Lakehouse from Holger Friedrich. He is going to talk about building Data Lakehouse in the Oracle Cloud. And Holger is from Switzerland. He's a very knowledgeable guy who knows a lot about data warehouse, data lakehouse, analytics, and data integration. And he has more like 20 years of experience. And it's a pleasure for me to introduce Holger. Holger?
Hi, and thank you for
Hey,
that kind
how are you
introduction.
doing?
Hello.
I did actually get a late, fun fact for Holger, and really it's that he likes to travel, and as I do, he's a fellow gin connoisseur.
Yeah, more
Which,
than is good for me, I guess.
yeah, well, yeah, but I don't know. A good gin is health to the bones. So
Yeah.
anyway, sorry, I didn't mean to hijack you, Holger. The floor is yours, sir.
Thank you so much. I'm trying to share my presentation. I hope that works out for everybody.
Yeah.
Do you
Yeah.
see it?
Yep.
That's
We can see
great.
it.
So, all right, and I'll start my timer to try to stay on time. All right, there we go. Yes, so thank you for having me again. And I'm happy to talk a little about building a data lakehouse in the Oracle Cloud, the way that I see it. As you can see from my video image and from my title slide, I'm based in Europe, and that's why it's already a little dark outside, and there's not that much light through the window. So, and I'm based in Switzerland, as the Matterhorn on the title slide tells us. Okay, what are we going to do? Short introduction. Then I'll discuss a little the evolution to how did we end up with data lakehouses, the characteristics that are set to be features of data lakehouses and how they came about. And then we'll have a look at Oracle's take on it, and we'll first have a demo of how this looks like, so that we can take as much time as we want for that, and then either we go through the slides with some more details, or you can just look those up afterwards when you download the presentation, but I don't want to take time away from the demo in the end. And then finally, we'll have some, a slide of conclusions. Let's see. So, quick introduction of myself. I'm from sumIT, Swiss boutique consulting company. And we started implementing data warehouses over 20 years ago. And now it's lakehouses, also known as modern data platforms. So marketing relabeled stuff every now and then. We do business intelligence, advanced analytics, and everything around data integration, engineering, mesh, also an evolution of terms in the recent years that largely mean the same. And our technical focus apparently is on premises. It's purely Oracle, really. And in the cloud, the Oracle Cloud with its services, but we also do a little other stuff. So we are Snowflake partners and things. But today, it's all about Oracle. Myself, I'm a computer scientist with a PhD in robotics and machine learning, 25 years in the Oracle world. And I do this data integration, where lake housing, and of course, also a little machine learning. And since a few years, I'm the CEO of our company and an ACE professional since 2010. Well, having said all of that, let's go to the question of what is a data lakehouse and how do we build it with Oracle? And for this, I will start off with a Oracle competitors slide, basically the guys that coined the term from Databricks. And they say data lakehouses, that's a brand new architecture. And I would say, with that question mark up there on the top, is it really? So if we look at that, we'll see from the late 1980s, we have these data warehouses. So they basically drew in data from other systems or files not on object store at the time, but files. And then we had ETL engines that would transform them, store them in a database in files, proprietary database files, but files in a past fashion. And then we had engines on top of that consuming that. And we would have engines inside the database, like, for example, the graph engine in Oracle that that can consume and transform and then provide data and provide results. And then those guys came along 2011 with their big data idea and said, well, this is all old stuff. Because now we want to also do semi-structured data, and we want it open source and on cheap infrastructure. And so they invented the data lake, which is basically just a glorified file dump, right? And on this, now they said you can run all kinds of engines and all kinds of things, also loading data warehouses from it if you want. And SQL is basically a yesterday language and stuff. And now everybody found out SQL is a good idea nonetheless. And it might be good to have an integrated security and whatnot. And so we come up with a lakehouse, where now the only new thing for me is basically that the storage layer of those modern engines is immutable storage or object storage. And their main engine runs on non-proprietary database file formats like Parquet, but it's not. Is it that different? Okay, well, let's go further. I don't think it's that different really. With all of that, also now this is also from the Databricks guys, a new process is basically being put into the arena. And there we see we have the raw format, so that's basically our ingestion layer, and then we have several layers, bronze, silver, gold, of processing the data and enriching it and applying business rules and all of these kinds of things. And the ETL tool of the day in their eyes is a notebook. Well, okay, so coding in a notebook, but is it really a new process and architecture in general? If I, instead of bronze, write persistent staging area, instead of silver, write foundation layer, and instead of gold, write access and performance layer, suddenly it looks like a regular data warehouse architecture, doesn't it? So yeah, the Lakehouse is sort of new in some technical respects, but it's also lot of stuff that we did all along for the last 20 or more years. Okay, so that's the message there. Okay, what do we want from a data lakehouse? And you can always think about who can provide all of that in an integrated fashion. We want security, so we want encryption everywhere. We want identity access management. We want fine-grained data access control on rows and columns, something that in the big data world you could hardly have with all of these tools and projects and things. And now the data lake has it, or the cloud vendors thrive towards having it on their data lakes. You want scalability, so sort of virtually unlimited compute and storage, and the components should scale independently. Compute and storage sounds to me like servers and storage area networks in the early 2000s, reinvented again, only they are more scalable now. And then we have the scale up and scale out, so large analytical workloads and lots of them. Okay, so that's what we want. And it should be polyglot, which means the data should be accessible via a multitude of APIs, via all kinds of storage formats should be used, and various languages should do that, and various engines should be able to access the data, like engines for machine learning, for spatial analysis, for graph analysis, for relational analysis, for whatever. And that should be accessible from everywhere, of course. Yeah, fine. And then to be very flexible, so very diverse workloads, small workloads, huge workloads, as I already said with the engines, different kinds of workloads, different access patterns and processing patterns, batch versus streaming, and all of that in several locations, hybrid, on-premises, in the cloud, in multiple clouds, wherever, with the already said scalability and elasticity of resources. And now we can always, while I talk about this, you can, in the back of your head, you can always think about, was that impossible with the Oracle architectures up until now, even on premises, or was it possible? Of course, here's something that wasn't possible so far up to that degree, that's management. The data lakehouse should be fully managed. So provisioning of resources, high availability should be built, should be automatic or easy. High availability, disaster recovery should be built in basically to be fault tolerant. You should be able to automatically restore stuff, have flashback queries or time travel like competitors call it. So the user interfaces should be managed. No installations of any software, maintenance, patching, upgrading, all done by someone else without interfering and interrupting your work. That's, of course, a very nice feature of the data lakehouse. Yeah, and then we want to have a very high integration with the cloud platform itself. So for monitoring and event analysis, for example, but also with the tools. And Matthew just showed us how this integration with plenty of tools is done in the Oracle autonomous database. That's really what we want from a data lakehouse like solution, right? And now let's go a step back and see, well, where's Oracle in all this with the security, flexibility, all the APIs and whatnot? And here is an Oracle architecture slide from 2001, right? Where we basically see we have data coming in from the left. We have a tool, Oracle Warehouse Builder, bringing it in, transforming it. We have already many engines on that can work on that same data mining, so the machine learning engine, the analytic engine, the OLAP engine, and whatnot. And then we can have access through Java tools, whatever you want. So it's pretty polyglot already. The only thing that we didn't have in that time, in my eyes, was the scalability to that extent, the autonomous, the management part. And of course, it was all, once the data was in the database, it was all in a proprietary data format. But we already had external tables, so we could read files on the fly and query in files. And then 2009, 8 years later, it's still more or less the same picture. Now this is like the bronze, silver, gold thing. We have staging, foundation, access, and performance layer. And it's sort of still the same thing, multiple engines, proprietary file storage in the database, but lots of interfaces and stuff, no management, no autonomy thing. And this goes on. 2013, we already talk about weakly typed data in the staging area, of weakly typed data and strongly typed data. And we have a knowledge discovery sandbox. I think that was the time when Oracle had bought Endeca. Then this whole knowledge discovery thing came along. And yeah, then 2014, we really had the big data world was here. And now in the data ingestion middle box, we have the raw data reservoir, an immutable raw data reservoir, which basically is the object store, right? That's the big data part. Okay, but all of that was already possible with the Oracle technology all that time. And now that's basically today. Might look different tomorrow because there are new services and things popping up every now and then. And I think we'll see more new services soon. But now we have this idea of Oracle, the lakehouse, being data integration, autonomous data warehouse, the object storage, the data lake itself, access and managed lots of other different tools and managed open source services, and which is very important on the lower right side, the data catalog, because all of what we've been talking about by now is impossible if you don't have a common metadata layer over your tool set and your service set, right? So but that's also old news. People try for decades to enterprise metadata management and these kinds of things. So that's not new stuff, right? Only now in the cloud, the vendors have a much better possibility to really implement it in a useful fashion than if you try to do it on premises. So a data catalog, that's very important. And that's a central service in the Oracle architecture for the Lakehouse, as we will see. As we will see now. First of all, high level, just to summarize the picture that we had, Oracle's take, as I see, I'm not an Oracle employee, on the data lakehouse is central, as Matthew already said, is our multimodal converged database, which with all of its engines that are in there. You know, we can do JSON, we can do XML, we can do Oracle text, so fully indexed text search like an Elasticsearch in the database. We have the analytic views for multidimensional analysis, and so on and so on and so on. Right? Lots and lots of APIs to the outside world, for lots of connections, for lots and lots of languages and this and that. We have self-service access, and then Matthew showed us how to do all of that. SQL everywhere. We got big data, SQL, Cloud SQL, and we got SQL in the database. We got SQL through external tables to files of multitude of formats, from CSV to JSON to Parquet on the object store. We have the data catalog that basically hosts all the metadata of all the building blocks of our Lakehouse architecture. We have real-time data access with streaming services that Oracle has as a service in OCI. We got self-serving and enterprise analytics with OAC. And maybe to that question that we had early on, you can have your fine-grained security in the Oracle Analytics Cloud, of course, especially when you use the metadata layer for the enterprise BI part. On the analytic views, you can do what you can do in the database, which is DPD and data redaction, which of course is always depending on the user logging in. So you can have it on both sides. Right, but I digressed. Everything that Oracle says what they do is nowadays CI/CD ready, and you can extract everything and put it in Git and you know, all that stuff that you need for running then and operating at the Lakehouse architecture. And all of that is available across regions, multi-cloud, so you can now use your autonomous database in Microsoft Azure, as we know, with these multi-cloud services. You can read through external tables and everything from S3 or Microsoft Blob Storage or Google Object Store. All of that is basically supported. And then we have also the OCI data integration tool to do pipelines into the data lake or into the autonomous database. So Oracle basically says, yeah, we got all these components. And of course, the database is a central one. But yeah, you can also just use Dataflow and write your own Spark applications and run Spark applications directly on the data lake if you don't want to use the database. But if you want to do a graph analysis or JSON, then use the engine in the database because it's all there integrated. Okay. Having said all of that, we'll now do the demo. And yeah, let's see. I hope that works. Now I have to basically go back and share a different screen, which would be.
Yeah, this is your last barrier between this and your gin and tonic this evening. So.
yeah, and I'm thinking about which one to drink. Okay, thanks for the motivational speech, yeah. Roger. So, as I said, the data catalog is really the central building block of the Lakehouse architecture in my eyes. right? Because it holds the metadata. And if it is able to harvest metadata from all the data holding other services and provide it to consuming services, then you really have a central hub for which everybody can use, right? So the data catalog service is important. What I did in our demonstration, and we're here on the landing page, basically, we go to the data catalogs. I have one here that I initially set up for the Kscope conference, another great conference, which I only can also in March. You should come to the Oracle to Redwood Shores, to our analytics and data community meeting, and in June you should go to Aurora, Colorado, to Kscope 23. So this is a catalog that I reuse now for that demo. This is a data catalog, and what I did is I used sort of the same data that Matthew used, this movie stream, publicly available movie stream data about movie goers and what they watched and whatnot. So the data catalog has basically, in my eyes, 2 or 3 purposes. One, it harvests data, metadata from sources to provide it to others, right? 2, of course, it provides it to others that then should do stuff with it, as we will see. And 3, you can enrich the data with, well, by means of a business glossary. Okay, so what we see here is we have data assets. In our case, we have a OCI public data lake, because this movie stream buckets that Matthew also took the data from are publicly available for all of us. And when we click onto that, we get some more information. Very interesting is I can give an Oracle DB schema name, because OCI public is a little long, so I just called it opt for object store, which we will later see. And now this one is an Oracle object storage asset. Database would be a different asset. And here I have buckets, gold, lending, and sandbox from this movie stream database. Okay. And there is a big harvest button up here, which is important. Now, if I go back to the summary, I have to, of course, define connections, which are in our case pre-authenticated requests to the object store in Ashburn, to these public buckets. And in order to then really look and harvest meta information, in case of files, I need a file name pattern that is basically used to analyze the file names and derive object names and stuff from it. And that is done, as we can see here, with regular expressions. And as it is with regular expressions, there are many examples there already, but you can have lots of fun with those, yeah, until you really harvest the way you want, maybe. Now let's go back to for the harvesting, we use jobs, so that we can, when we have a harvest job, we can rerun it when we want. And it's just basically when we can store them with names, like, for example, everything from the movie stream sandbox, and then we can rerun it. We can schedule the reruns to every night to update our metadata and whatnot. So that's pretty neat. We can do that for all the sources and for all the buckets and databases that I want to get stuff from. Okay. And now I say, okay, I go to I want to show the third part. I go to the landing bucket, and I see what kind of entities have been harvested. And I see, for example, here I have the customer. Okay, so there's a file in there, or several files. It's a CSV file, and it contains customer information. Apparently, that's the metadata that I have. Now, what I did earlier is I uploaded a business glossary. You can upload in Excel format a business glossary. And the system now tries to match via name. This object's called customer. It does a name match with this business glossary and thinks, what could all what enrichment data describing business data could basically be used to enrich this. Just to show you, I go to an attribute, like for example the postal code here. That's the harvested information about it, and there is now a recommendation to use this part from my business glossary to enrich this information. And once it's enriched, others can use it. And this gives a description about postal codes and how they are used worldwide and whatnot. And I can just accept this if I want. And now my postal code has additional metadata attached to it. So that's quite nice, I think. So now let's just imagine we want to build a data lake house. We have, there's people ingesting stuff in our data lake. We have a bucket structure. Then we use the catalog to basically harvest all of that metadata. We can use schedules and the jobs to do that on a regular basis. Wow, now we have files in the object store. We have metadata in our data catalog. What to do with it? Well, wouldn't it be nice if we could quickly get to analyze this? And here comes the integration between the data catalog and the autonomous database into play. So I'm very happy that Matthew did not show this earlier because he was focusing on the tools. Now I have to change to a SQL developer. Or I will change to my SQL developer to show you. I have to find my SQL developer. Here it is.
We did that specially for you.
That's very nice. Very nice.
Perfect. We can see your screen.
Yeah, great. So what do we have? What do we have to do now? I mean, I have an autonomous database, and this autonomous database is sitting somewhere in a compartment in my tenancy. And now I have to, of course, point it to my data catalog. One side note: in order to make all of this happen, also the harvesting from that the catalog does, now the communication between the database and the data catalog and whatnot. Of course, for all of that, you need groups and grants and policies in the Oracle OCI security settings, right? But once set up, this is secure for all the tools that participate in the process. So the security that we wanted from our data lakehouse, unlike an old Hadoop system where that was always a nightmare, is really not easy because you have to set it up correctly. But once it's set up, it works. And it will keep on working regardless how things are patched, upgraded, and whatnot. Okay, so that's important. So now what we want to do is, and I already did that, we want to use the resource principal functionality of the autonomous data warehouse. And we just have to here enable it with this call. The admin of the autonomous pluggable database has to do that. And then the admin tells my movie stream database user that I have that it also can use it. Okay, so it enables the user to use the resource principal. We can check that. We have the resource principal credential there. And now what can our movie stream user do? We can see here in line 6, it is allowed to use that resource principal. And now first thing we do is, could we now, in theory, with all of that, start reading, building manually external tables to read this movie stream data? So basically, I do a list objects call from the database to the object store. Can I see the files? Okay. Because the catalog doesn't give me any access to anything, right? It just gives me metadata. The access has to be granted through the OCI security or configured. And what do we see? We see all of these files in the data lake, right? So those are our files in these movie stream buckets. Okay, we have access, but those are quite a number of objects. And there's also the sales object, the customer sales object with monthly paquet file slices. I don't want to write an external table by hand to have these, as external tables to be able to query them. So what I do, I basically say, okay, I use this DBMS cat package to set the data catalog credentials from my autonomous database. So that now says, okay, you can use this OCI resource principle as credential to talk to data catalogs. Again, the policies have to be there in the OCI. And then I can say, hey, now I can use data dictionary views basically that now reach out in the cloud and say, what catalogs can I see? And this is, of course, now dependent on the policies that are configured in the OCI security. And there's one. There is one in Frankfurt, and it's that case called 22 cat that I've been using for this demonstration. Okay, I say, well then, set the data catalog connection to the region and this OSIT of this catalog. I do this, and it doesn't work. Ah, I did it before, sorry. Should have unsaid it before. And now I can basically go and say, and now I can ask this all dcat data catalog assets view, which is now basically reaching out in real time to that catalog and says, hey, what kind of assets do you have? And the catalog comes back and says, I have this OCI public lake, which is, if you may remember, exactly what we had. And I can go there and say, okay, tell me all the entities you have. And now I get, look at this display name column, I get all the entities that I have there. And I have, if you look in the folders, I have movie stream goals, landing, and sandbox. So now the database knows what the catalog has as entities. And we go to the next step, which is basically saying, okay, that's already been run. Now I'm saying sync, run a sync process with that DBMS catalog, okay? And the synced objects should be in the asset list, and that is my public data lakes asset, that the folder basically of the, let's see, we can run this. That is the sandbox folder, and the sandbox folder has those keys for the folder and the asset key, and I give the asset key and the folder key, and I say sync with the sandbox, basically. And we do that. That may take a second or two. What it does now, basically, is it goes out, asks again about all of those entities from the catalog, and then in the background creates a schema and external tables against the files based on the metadata from the catalog. So we can look here in the load operations. There's a load operation dcat sync 95. And here it did stuff. we can look at that. Okay. And now we have all of those entities already because I ran it, so it did it again. And that's basically all we have. Okay. Well, apparently we did already the syncing. And now let's go in here. Now we can see, for example, one of the external tables is the dcat object landing schema that was created, and the genre table that's here. That's now really an external table, which I have the select grants, now the read grants on. And now this is reaching out to the file and reading it. Okay. So basically, I did not type a single letter to create 20 or whatnot external tables that reach out to the now what's it called, object store. I just took the metadata from the catalog, and the autonomous database did all that for me. Okay. And so now, and let me just do this. I create some views on 3 of those external tables because I want my movie stream user to also be able to create views on them. Okay. Now, just for us to be sure, what's the amount of data we're talking about? We have 25 million sales records. What's that? 150,000 customers, 731 days, and 25 movie genres. Okay. Okay. Now I'm going to build 2 views. One is called DWH fact, which takes the exact same data that's already been loaded into the database, like the one Matthew had, the sales, time, customer, and genre. And I do a second one, which is the same select, only in this time, I'll take the data directly from the data lake through these external tables that have been automatically created for me. Only the time dimension is local. Another great thing about the Oracle solution for that is we can have a Parquet file, and in that case, one Parquet file or several, and 2 CSV files on the data lake, and we join it against the time dimension in the database. Okay, so we bring all of that together. And now we see already a little difference when we do an explain plan to get the data in the DWH. Of course, it does things local, table access, storage full here, for example. When we use the view that we created, the LH, the data lakehouse view, with this mixture of heavily used object store and a little database, we have external table accesses. So what we expect, right? Okay, so now let's see whether these 2 views really work and whether it does make a difference. And so we have a select here that sums up the prices and the number of customer IDs, so number of viewers for the entire year of 2019, okay? And if we make the explain plan in our autonomous database, we see that's the data that is already in the database. We see that we use something here that's called the key vector transformation, which is very good for these star schema type queries. And it's quite a long way to do things here. There's the vector part. And that should be very, very efficient. And we'll see it when we run it. That takes us on these 25 million against 150,000 against 1,000 against something. That's there in 0.3 seconds. Well, that's the power of Exadata on which the autonomous database runs on. Now, if we run that against the data lake, so we have to take those 25 million from the data lake. Granted, it's in Parquet files, so column-oriented binary file format, but it still has to go through it. And in order to bring it together with the other dimensions, basically, we don't have a key vector transformation because it's not residing in the database already. So we have regular hash joins. And if we do that, we see that this takes somewhat longer. Okay. So it should be there in 20 seconds or something. And we'll wait it out here because then we'll go over to the browser, to the Chrome browser. So this took 27 seconds instead of 0.3 seconds. And that is something that I'd want to basically point out. This whole big data and data lake, data bricks, whatnot people tell you, you have unlimited CPU in the cloud, and so you don't think about efficiency anymore. But yeah, so if you want to run that much faster, and in other engines maybe, then you may have to, use much more CPU, which would most likely come at a higher cost. Okay, so that's something to think about also. Yeah, and just for you to see, we have here's a ratio to report thing, which really does an SQL analytics, which does compute the weekdays and how they participate or contribute over the quarters of the year to the sales. And that's also, again, 0.3 seconds on the warehouse tables, the already ingested data, and it'll take about another 20-30 seconds in the data lake. So long story short, great, we can really get to the data, and we didn't have to write a single line of code. We just had to set the security up, use data catalog to harvest, and then the database would do the rest for us by talking to the data catalog. Okay, 26 seconds, as I said. But the second good news is, even if we don't ingest it, if we take the time and wait, we can run very complex SQL, like this ratio to report and whatnot, on the data residing on the data lake in different format. There's some JSON there, there's CSV there, there's Parquet there. That's data lakehouse heaven, right? So before, and as a last step, I will go back and share again, just a second, my browser, and share the screen again. I need the browser. Let's look at the performance hub of the browser quickly. That's the autonomous data warehouse. And now, a very interesting thing here is that's the performance hub of this autonomous database. And you see here these spikes. So it's a 4-core, 4 Oracle CPU autonomous database. Now, those spikes were when we were doing the stuff with the directly on the data lake. Okay, so if we look at the wait events here, we see lots of CPU. Yeah, that's two of whatever CPUs, or lots of CPU, and we see the TCP socket TJAS. That's a network event. That's basically the database reading from the data lake. And any other engine, being it Spark, being it the Databricks engine or the Snowflake engine or whatever, has to have to do the same thing. So unless your cloud provider has a much better networking than OCI, which I would doubt, right? Yeah, it takes time. And it takes lots of CPU, because the other queries, the in-database queries, took half a core or something to do the same thing. So if you think about lake housing with what technology, look at this. Okay, final thing. Now, I've built, what I did was I used Oracle Analytics, and I set up 2 data sets. And just to show you, there is the data lake data set. And here on the other side, I have the data warehouse data set. And the data lake data set, do a mouse over here, and I don't know whether you can see it, but it says DCAT $object landing genre, right? And the customer sales is the DCAT blah blah gold customer sales. So this data set in OAC goes directly to the data lake through the autonomous database structures that we built with the help of the data catalog. I can do all of this profiling. I can do dashboards now on the data lake through the autonomous database, using the security of the autonomous database, using analytic views, using everything. And here I have the same thing with the data set, but this time with the data already in the database. And now what we want to do is, I have the same dashboard on both of them. Now we take this workbook. That's basically now for analytical queries going against the data lake. And you see, takes a little time to run. Well, it will take some time to run. And this one is the same thing again. Oh, sorry, that's the data lake thing again. Now this can, sorry, screw up everything, because now I have lots of queries that may be queued, because the database may not have enough power. Oh no, it's quick. So that's the data warehouse, right? That's 1 or 2 seconds for these 4 queries and rendering them. Whereas going against the data lake takes some time, okay? And when we look, last step, when we look at our performance views again, now we see here and we do the SQL monitoring, we will see a lot of queries that were the ones that I stopped, but a lot of queries that are still running and running now ready for 33 seconds. So interactively against the data lake directly might not be too good an idea. So if you want to do analytics, interactive analytics, hey, there's something coming and we can compare. Yes, it's the same thing if we move back and forth. Then bring it in the database as Matthew showed it and provide it there. Okay, so let me get to the conclusions because I think my time's up. I will go back to the share. All right. Okay. Let me do it this way. I'll have to share again, just a second. And so, okay, conclusions. And you'll find more details about the different Oracle services that I was talking about in the slide set. Okay, my conclusion is, first of all, architecture-wise, data lakehouses are an evolution, not really a revolution. Okay, but this whole integration in the cloud systems and the scaling and the management, that's really cool. And Oracle offers multiple deployment options, more than competition. You can do it in their cloud. You can do it over several clouds, since you can have the data lake in a different cloud. You can do it hybrid. You can have part on premises and part in the cloud. The catalog is not available on premises, of course, but you could do Exadata cloud at customer. Then you would have autonomous there, and you can build your data lake on your local file systems if you want. Then you would only need the catalog in the cloud. Okay, and of course we have this very mature converged database management system with a lot of different engines for all kinds of purposes in there, plus all the tools and services around that I was talking about, most notably for a lakehouse, the catalog. But having said all that, as we have seen, in database computing uses much less CPU than the other way, at least in the way that I set it up. And it eases development very much, also like with the tools that Matthew showed us, and it scales very well, as we know since decades now. So if you want to build your lakehouse, I'd say build it with Oracle. That's a very good solution. Yeah, and with that, I'm finished.
Perfect.
And hope you had fun with that.
It was amazing. It was amazing, Holger. I have to say it. I love it. I truly love it. It shows a lot of, yes, it shows a lot of information and in fact, someone loved it so much that, excuse me, Hrusikesh Kopar, I hope that I pronounce it kind of well. So it's asking you if it is possible that you share the script. He said that this is most stunning script he has seen for the purpose. Is it your IP? Are you willing to share for learning purposes? No pressure, just a hope.
Yeah, of course. I mean, they are taken from some live labs and with stuff from me added to it. So it's there's nothing secret about those. And it's, as I said, that's why I use the movie stream data set. Also, it's a public data set, so everybody can play with them. So we can sort it out later, I guess, Roger, and it'll whether we do that via Slack or whatever. But yeah, or if you want, of course, everybody who is listening, you can always contact me directly also.
Yeah. So, but I will send an invite to you for the Slack channel that we have in our Slack workspace. There is a data lakehouse special channel that will love if you can join us. And also Bjorn said that it's a fantastic overview of all the aspects of a lakehouse architecture. I completely agree, and thank you so much for that.
It's really, you kept on talking about how slow certain things were, but for 25 million records, I remember back in the day sitting and waiting 20 minutes like that. So, I think it's all relative. It really is.
Of course. But I don't know whether you've seen that. Do you remember when Larry Ellison at an open world demonstrated the in-memory option for the first time? Where they basically say we can go through 1 billion records within a few seconds or something. So as you say, it's all relative and depending on the tools you use and how optimized things are. There you have it. Yeah.
Yeah, I've just add my thanks and agreement with the Elo. Super presentation. Very good.
Awesome.
You now have our permission to go and have your gin and tonic. And all right.
Hope we'll be able, and all of you that listen, hope we'll be able to have some gin and tonics in person soon.
Absolutely.
Maybe at the Analytics and Data Community
That will
Summit
be
in March.
the perfect place, the perfect moment on March 24 to 26. 14 to 16 of March. Thank you so much for that, Holger.
And I'll definitely spot you
if
you're going to be at Cloud World. I'd love to meet up with you as well.
I'll be there. I'll be giving a Jason in the database talk there. So we will definitely meet, Roger. Okay.
Thank you so much, Holger.
Yeah. Bye, everyone.
Thank you. Much appreciated, sir.